Timeless Decision Theory (TDT), formalized by Eliezer Yudkowsky in a 2010 paper for the Machine Intelligence Research Institute (MIRI, presents a foundational shift in decision theory by resolving long-standing paradoxes through a focus on logical correlation rather than strict physical causation. The core principle of TDT is that a rational agent should model its own decision as the output of a deterministic algorithm and should choose the action that corresponds to the algorithm's output which, when considered as a logical fact, leads to the best possible outcome across all instances where that logical output is relevant. This approach allows an agent to reason causally, considering how its decision logically influences and is influenced by other processes, such as predictions or simulations, even in the absence of a direct physical cause and effect link. The theory is explicitly designed to deliver what Yudkowsky argues are the intuitively correct answers in classic decision-theoretic dilemmas. In Newcomb's problem, a TDT agent 1 boxes does so because it recognizes that the predictor's action is logically correlated with the output of its own decision-making process. The agent's choice is the very thing the predictor foresaw. Choosing to 1 boxes the output that logically implies the predictor will have placed the $1 million in the box. Conversely, in problems like the smoking gene variant of Solomon's problem, TDT prescribes the causally correct action, such as chewing protective gum, because the correlation between the decision and the negative outcome is spurious, stemming from a common cause rather than a logical link from the decision itself. A key technical innovation of the paper is the introduction of timeless decision diagrams, which augment standard causal Bayesian networks. These diagrams formally represent the agent's decision as being determined by an abstract, latent computation. This allows the model to capture logical dependencies between different instantiations of the same decision algorithm, such as an original agent and a perfect simulation of that agent used for prediction, by using these diagrams. A TDT agent can correctly calculate expected utilities that account for how its decision type influences the environment, maintaining what Yudkowsky terms determinative symmetry. The philosophical implications of TDT are significant, as it challenges the primacy of causal decision theory by arguing that an agent's decision can determine outcomes that are temporally or causally prior, not by changing the past, but by being a logical fact that was always true. Yudkowsky further argues that TDT agents are reflectively consistent, meaning they would not wish to change their decision algorithm when facing the problems TDT is designed to solve.